Hey everybody, it's Norm from Tested here at Valve's headquarters up in Bellevue, Washington, where I'm here today checking out a bunch of newly announced hardware products. There's the new Steam machine, Steam controller, which we're going to cover in a separate video, but most exciting to me is finally the reveal of Valve's new VR headset. This is the Steam Frame. Now, if you recall, the Valve Index was announced almost 6 years ago now, and I first checked that out. And since then, we'd all been curious about what if Valve was going to continue making a VR headset, if they were still into VR, and now we have some answers. So I want to run through some of the specs and how this works. I want to jump into a conversation, deep dive with some of the Valve engineers who worked on the Steam Frame and have lots more to share afterward. Take a quick look. It's actually more akin to a standalone VR headset than a tethered PCVR headset that we've seen in the past, like the Valve Index. In fact, you can almost call it very inspired by the Steam Deck in that it's a device that can run games locally as well as stream them, both flat screen and VR games. So in the front here, in what they call the compute module, let's take a look at this. This is an engineering prototype. The entire headset, the guts of it, is basically in here. This is about 185 grams, and that includes the displays. There are two 2160 by 2160 resolution custom LCD panels here behind Pancake optics that they've designed for roughly 110-degree field of view, adjustable IPD via a dial, and then also a processor. They're running a Qualcomm Snapdragon 4nm processor, their latest one, to run their version of SteamOS. Now you might be wondering, wait a minute, Qualcomm, that's Snapdragon, that's an ARM processor, and PC games run on primarily x86 and on Windows. And Valve has done an incredible job on the Steam Deck side of making Windows games run on Linux with their Proton translation layer. On the Steam Frame, they've actually worked on a project called FEX to adapt x86 content into ARM and have that emulate as well as run Proton, so you can run your entire Steam library of games as well as PCVR games locally on the headset here. It also does stream content from your PC, so if you have a beefy gaming computer, what comes in the box is this USB stick, this dongle that's basically a Wi-Fi 6E router, plugs into a USB port, USB 2 or 3, and then does some custom compression work to send a high quality signal of that game running locally onto then your headset. Has two new controllers here. These are not like the Valve Index controllers, although there will be an accessory to allow you to use them without having to hold on to them. But you have controllers that are more akin to what you find on a traditional gamepad, including a D-pad on the left side, two thumbsticks, ABXY buttons, and capacitive buttons on ABXY on the D-pad, on your thumb rest, and also finger sensing, as well as a grip button and two trigger buttons. A lot of input options. This and the world are now being tracked on the Steam Frame using 4 cameras, so inside-out tracking. Doesn't use Lighthouse base stations, and so there are 4 ultra-wide view monochrome cameras that do the world sensing, the controller tracking, as well as a set of IR emitters behind the headset here that blast into the world, so you can also track and use this in the dark. Look at the headset right now, and you can see there are these 4 ultra-wide monochrome cameras for world tracking and controller tracking, both the Steam Frame controllers as well as the new Steam controller. There are a pair of microphones on the bottom. There are vents for air intake and exhaust that goes out the top as it's being powered by the Qualcomm Snapdragon processor, and then also speakers. On the inside, you have a removable face gasket, and they will have a spacer option for people with additional eye relief needs. There's a kind of light seal nose gasket that is removable right there. And on the top, you can see an IPD dial that adjusts your IPD to fit for your needs. There is eye tracking for their foveated streaming And then, interestingly, there's also a micro SD card slot, not just for expandable storage, but because this runs SteamOS, you can drop in literally the micro SD card you have in your Steam Deck and play those games natively and immediately in Steam Frame. The whole compute module detaches with these 3 latches that you toggle. And so this becomes a modular aspect where you can see this custom connector at the top. That also, you can see the IPD adjustment mechanism that's turning that lead right there. And that's connected to a single cable to their battery pack, which is also have the removable pad. It's a segmented battery, so it can have this contour that fit the back of your head, and that counterbalances the entire headset. So the whole weight with the compute module and the headset is about 435 grams, with the option of an ergonomic strap that you can hook onto the top, hook onto the back to take more weight off the front of your head. Most of this is made with plastic, including a lot of their pancake lenses, so this is extremely light at 185 grams for display panel, compute, and lenses. Basically everything except the battery. Volume right there. Power button right here. And also an expansion slot on the bottom. It's also a custom port, but the hope is that might enable some type of additional pass-through camera for color pass-through, if that's something that they're thinking about in the future. It's such a big departure from what we thought Valve was going to do, what they had been doing with their partnership with HTC, with the Vive, with their development of the Index, and it's the latest evolution of Valve's approach to VR. There's much more to talk about, so for that we're going to jump into the conversation I had with Jeremy, Joy, and Lawrence on the Valve team to talk about all things Steam Frame. Let's jump in. All right, Jeremy, Joy, Lawrence, thank you so much for having me here to check out the Steam Frame. Seems like it's been a product that you guys have been working on for a long time. I see a lot of DNA of Valve Index, but also Steam Deck primarily, and what you guys learned from making Steam Deck. But it's a VR headset, so I got some nuts and bolts questions I want to go to first. This one has what you guys call, is that a core module?
Yeah.
Is that in the front? And that's not just display, optics, but processor.
Yeah, this has the entire processor on the inside. It's a 4-nanometer Qualcomm ARM chip.
Is that equivalent to, I know Qualcomm has, like XR2 plus Gen 2.
Yeah,
I
believe it's a little bit after that in capabilities. It's from a different line of processors, but it's now part of the XR series.
So that's an ARM processor that you're using. That does all the processing for your inside-out tracking. This is now 4 cameras, you said? Is that right?
4 cameras on the outside used for tracking. They're very high field of view monochrome cameras. They're also extremely good in the dark, which is why we have IR illuminators to allow tracking in complete darkness. But there's also 2 additional cameras on the inside as part of the eye tube that allows for eye tracking.
Right. There's so much here that, like you pointed out, there's an SD card slot here to load in your the same games that you might have on a Steam Deck. There's an expandability port on the bottom, but of course, display and optics. I remember you, Jeremy, told me like when you guys did the Valve Index, a lot of the Valve Index design was finding the right panels and then kind of building a headset around those panels. It seems like here, it's the right processor panels and optics. Those things have to work really well together.
Yeah, we really wanted to find a balance for this product. I think Valve Index had certain goals which were really around the high-end, premium, high-fidelity experience. On this product, it was much more inspired by the Index as well as the Steam Deck, as you mentioned. So when you make those trade-offs, we very much wanted to put a lot of the attention into the processor. This has 16 gigabytes of RAM, which means you can play a very extended portion of the catalog when you have standalone play. But that said, the optics are very good, and we're very proud of them. So these use new pancake optics that we've designed in-house. They have a very good eye box, which means you can, as you look around the scene, the world feels very stable. It's sharp edge to edge, and it's also a compact folded light path, so it's very shallow. and also very lightweight. I mean, you can feel the core module.
That's 185 grams,
Yes.
you said, right?
Yeah.
I know that with pancake lenses, it takes a lot of light, with the polarization and all the lights folding. So I assume your panel is pretty bright. But
Yes.
it's an LCD panel, two LCD panels?
Yeah, these are two LCD panels. Each
tell
one
me
is
about-
at 2160 by 2160.
So square panels?
Yep. I should say it's a square aspect ratio in terms of the graphics we send it. They actually have little notches cut out.
Got it.
In terms of the ergonomic design. You can actually, from some angles, almost see them inside. Like you can tell in an effort to get rid of all the weight for the product, you can basically see into certain portions of the display. They are also very high refresh. So similar to Index, these go from 72 hertz all the way up to 120, and then a 144 experimental mode.
Tell me about the process of finding these panels and the characteristics that you're looking for to make this experience.
Yeah, similar to the things we've learned in the past. It carries that same trajectory forward. So we want very fast trends, very fast response times. So you think about sending one 144 hertz frame to the next one. That's a very short amount of time. You need the panel to fully transition. We care a lot about sharpness, edge to edge, and pixel quality. You want them to be crystal clear. And those are the things we really prioritized.
Have you found that the supply of panels have evolved to a point where you guys, was there a jump in that technology? We found low persistence, high pixel fill panels.
Yeah, it's been very impressive. We are working with a few suppliers now, and the fact that what used to be a bespoke one supplier on the planet who knew how to make them, we've now seen it where lots of people can work with us to create this tech.
We're a long way from the original HTC Vive days of repurposing phone panels.
Right. Yeah. But they are LCD panels. What's the brightness that you're quoting?
We're targeting a little above 100 nits at the eye, but of course, as you mentioned, with pancake optics, they're substantially brighter at the panel.
So that's removable. So it must be modular to some sense, right? So can you talk a little bit, like Joy, what the aspects of that people can use maybe after the fact, what you guys are thinking of, for how people will customize these?
Absolutely. So you'll notice that the audio is integrated into the head strap along with the battery, and that part is removable. So we prioritize making this a very lightweight, very comfortable, seamless solution. And so we have two drivers per side here. That's vibration cancellation. They're actually oriented in a really interesting way on either side. Because as you notice, it's right next to where the tracking system is, and there's an IMU on here that it would interfere with otherwise. And so we did a lot of really great things to make this a good audio experience. And then we also have two microphones on the bottom for voice pickup as well. So if you remove this, you'll notice that, this is very easy to swap out. We're not ready to announce anything today, but certainly we understand that there's different needs for the audio community, some premium solutions, and then some sort of ease of use solutions for comfort and portability. And so we want to support the needs of our community, but this will be the base shipping device. And then there's also a battery on the back. And again, nothing to announce today, but we will be exploring different options that will connect to the core module through this connector right here.
Yeah. This battery, is it a curved battery that you have designed?
It's a multi-cell design.
Yeah.
Yes.
Yeah. Can you talk about capacity? What's
21.6 watt hours.
Yep.
And there's so many different ways you can run.
Exactly. Yeah. So it's hard to put a length of time on that. It just really depends on what you're doing. Streaming obviously will last much longer than playing standalone.
Yeah. And there is a USB-C port on the back. So if you wanted to bring your own battery, you can also augment what's currently the capacity that ships with the device.
Is this only power in? Do you have any data
It's also
pass-through?
USB 2.
Okay, USB 2.
Yes.
But there's no way, because streaming it's a wireless solution right now. We'll talk about that for sure. But this is it feels like a departure from what you've done in previous PCVR headsets, and that there's no display port input.
Correct.
You're doing inside-out tracking. There's no way to
I will say, I'm someone who's spent a lifetime looking at pixels very close up. When streaming, I've even had to change the desktop background from my SteamVR on my PC to SteamVR running locally, because most of the time I can't tell. Yeah. Like it with the foveated streaming sort of multiplying effect, it's just under all conditions where it's working, you just won't see it.
So you think of this really as a separate product, separate category from the Index, even though they're VR headsets, the Index controllers don't work with this. You don't need base stations anymore. Is the Index kind of going to be retired at this point?
Index is no longer in production. We still love it. We intend to support it indeterminately in the future, as we do with previous VR products as well, but we're no longer going to be producing index.
Okay, so let's talk about the gaming experiences, because there are like 3 distinct different types of ways you can play games on this. First, for PCVR streaming, you guys have this wireless, basically a USB router here. So tell me about this and its capabilities.
Yeah, so that's a 6 gigahertz, essentially endpoint that you can plug into your PC via either USB 2 or USB 3, and it allows for a dedicated communications to the headset's dedicated radio in the 6 gigahertz spectrum.
So even at USB 2, you're going to
Absolutely.
hit max bit rate, I think that's like 480 megabits per second. What's your streaming cap, and how do you deal with like the streaming bit rate from this to your headset?
So the streaming bit rate, we should confirm later, but it's on the order of 250 megabits per second. But that's the base rate. And remember, we talked about all those techniques that allow you to have a higher effective bandwidth, because we're really steering them to where you're looking. So you can think about it as almost a 10x multiplier, depending on the ratio of the pixels in your where you're looking to the pixels in the full frame.
To clarify for the viewers out there, you're talking about foveated rendering. This is eye tracking, but the render, it's foveated streaming.
Streaming, we're calling it.
So the desktop PC or laptop that you have this plugged into, you can run your games. You're asking your dedicated GPU to run it full resolution, super sample, as high fidelity as you would normally get for PCVR, and then you have, through a automated dynamic way, making sure those 240, 250 megabits is focused on just where you're looking. At a low latency.
Yes, and in our experience, it's essentially seamless. Obviously, you can report on your experience, but we're happy with it enough that we decided now's the time to ship this product.
And typically, there's a trade-off in like latency, compute, and bit rate and fidelity. How do you find that happy medium to make sure you can get the max?
Absolutely. There's it's always a balance, right? Nothing comes for free. We're trading latency and even robustness, right? You can think about when you send information across that wireless link, you're always going to lose some of that information. So there's things like forward error correction. There's all sorts of other techniques that come into play, and we have to balance all of them. But we care immensely about latency and robustness, and those were sort of our top 2. And then to make sure that you didn't see those compression artifacts, that was the technology that actually came about last, which is why we were compelled to put the eye tracking tech in this headset.
And that's on by default. That's a standard.
That's on by default. In fact, I'm fairly sure there's no way to defeat it. It's always existing. And once again, it doesn't require the developers to take any action on their part. For foveated rendering, they have that option if they'd like, but it's not compulsory.
I know for a lot of PCVR gamers who do streaming, they buy high-end, various highest end routers, right? And what is the highest Wi-Fi spec this might support if someone wants to use their own?
So this is a Wi-Fi 7 capable device. As we talk about the full system end to end, we're talking about it as a 6E experience because this dongle is 6E.
But if they have a Wi-Fi 7 router, they can use their own solution, what they're happy with, their configuration. Will that still tap into the foveated streaming?
Yes.
That's just on SteamOS side.
Exactly.
We're like Jeremy was saying, we're really excited about this new foveated streaming technology because it doesn't require the customer or the developer to do any work. It's just a system level feature that automatically sends the most important bits directly to where you're looking on the display, and only the most important bits are going across that wireless link.
And at that frequency, direct line of sight is obviously the best, but this is ideally used for in the same room. Is that the idea?
We're gonna let people decide what works in their environment and tell us as we send out the dev kits. I personally am in my household, I can set it up in one room and use it a few rooms over. But your experience may vary. For those people with excellent home Wi-Fi, once again, you can do anything you want at Valve. We're fortunate to have amazing Wi-Fi, so we don't, strictly speaking, even use this. We can just walk around the entire building and have a Wi-Fi experience that's building-sized. But for the home user, we think this will be a wonderful solution.
Okay, so that's PCVR wireless streaming. The other things, and really impressive because you talk about this being an ARM processor. It's the first time you have Steam officially running on ARM. Tell me about how that works with Proton and with now the emulator that gets ARM.
And actually, before you mention that, because there's actually four ways. The one that we did not test today, right now in this session, is regular PC gaming streaming. So you can also stream very high fidelity AAA
Non-VR
non-VR titles
right.
into that same giant game theater, but also using the same streaming technology.
Yeah.
So there's actually 4 ways to play.
Right. There's VR that's streaming, VR that's local. There's flat screen streaming, which I for extended battery life, and then flat screen local.
Yep.
So flat screen local, you have this virtual cinema display. You can adjust it. You can have pass through. I'm sure that works. But those it sounds like developers, just like on Steam Deck, don't have to do anything. They're making games for x86 for for Windows, but you now have it running SteamOS ARM.
Yes,
Absolutely. We're super proud of that trick.
Yeah,
It's,
and our hope is developers don't have to do anything. So, for example, Hades 2, Supergiant was happy to let us use this demo today, but they didn't do any work. That is actually just the same game that is downloaded to PC for PC gaming. One of the reasons we're opening developer kits is we do want more developers to try it out and see how their games will play standalone, to see if we missed anything and what we can do to improve that developer experience to bringing games to Steam Frame.
I know that Proton's been continuously updated, and it's been really surprising how seamlessly it's worked. But at the translation layer, you're kind of adapting the API calls. How does FEX work, and is that more does that need to be updated on a per game basis, or is that just like one and done? You're getting as long as ARM can run as x86.
Yeah, it's very analogous to the trajectory and the roadmap we did for Proton. So FEX has been under development for a while. Like it's a fully open source project. You can go check it out after the session and look at all the commits for every single game. Basically, as each new game comes online, they might explore, in terms of performance, certain implications where, oh, this game doesn't work well because it's doing the following sequence of CPU calls, like, oh, nobody has implemented that specific x86 extension. We didn't think it was needed, but this game requires it. So when we first started bringing FEX online, maybe 1.5 to 2 years ago, it was mostly games didn't work. And then once in a while, we'd find games that worked, and it was a very short list. And recently, by recently I mean about a year ago, we've sort of transitioned to the point where now I expect games to work. So I'll pick a random game from the back catalog, launch it, and almost all the time it works great. We're still in that early part of the knee, though. So once in a while, you'll find a game that will be running, and it'll be like 15 hertz. And you're like, this should be more than capable of that. And then you submit a ticket, and a few days later, it's now running at 200 hertz, and there was a bug. So we're in those early stages of optimizations, but that's one of the reasons we're so excited to put it out. We're also, just along the same lines, going to be starting a Steam Frame verified program, analogous to Steam Deck. So when you're playing standalone content, users won't have to go through that testing for themselves. We're going to be doing that hard work, and you'll just go to the website and confirm that the games you want are
both
expected
for
to
flat
work.
screen and for local VR experiences as well.
For all types of local games.
Well, I remember like Steam Deck, you guys had a targeted performance, kind of profile that was determined by the display you guys set and kind of the power draw. Really, is that how you think of it here? With
No,
this
it's a little
Qualcomm
more
chip?
variable. Simply because Steam Deck, for example, had that 1280 by 800 resolution, and while you could render at other resolutions, it sort of wanted to be at that native res. With Steam Frame for a VR virtual display, there really is no native resolution, and nor is there necessarily even a native refresh rate. We showed you content from 90 hertz to 120, and 144 looks great as well. And so tuning that knob very much is something you would want to do per game based on the type of experience. Like for fast Twitch gaming, you might prefer lower resolution, very high frame rate. And so it's a sort of wider dimensional space to choose what's appropriate for each game.
How would you say compare performance of just the game performance on Steam Frame versus on like Steam Deck OLED? Are they comparable? Is it this more powerful? Just the games.
I would say that Steam Deck is a little bit more powerful than Steam Frame. I think if we're like one way to look at it is in TDP. So I think Steam Deck, like a sweet spot is 15 TDP, and Steam Frame I believe is closer to 7.
Yeah. For the game portion.
Yes.
Of it, right. Because there's overhead for
tracking, for the displays themselves.
If you turn on pass-through, that's probably consuming a lot of power as well for the cameras. Yeah, and these are things.
And we're going to further optimize it over time, but it really is a trade-off of battery power, thermals, and processing ability.
And then finally, you can play local VR games here. right? So, and that's also between games that are maybe developed for Steam on Windows and you know ARM-based.
Yeah, so I
mobile
mean,
VR games.
it is kind of like a myriad of ways.
Yeah.
Like you said, you can be playing ARM games made for ARM, but also games made for x86, and
Yeah.
it could be VR or not. And yeah, our hope is that customers don't have to worry about all the differences, and they can just look at their Steam library and say, "Oh, I want to play this game," and then it'll launch and it'll do what they expect. But yeah, it will. Yeah, the goal is that it will support all of those things well.
Will developers have to do things to make sure they tap into the camera properly and take advantage of all like the mixed reality features, like you're exposing things like the hand controllers and.
I guess I would say that of all the ways we're looking at expanding right now, we're not putting that much of a priority on the mixed reality to begin with. We certainly allow it under certain conditions, but we're very much excited about what I would call the existing Steam catalog.
Yeah.
Like, I think one of the superpowers of this device is, like, if I think about Index, I would go into my VR room if I wanted to do VR, or not my VR room, but my room with my VR PC. Or if I wanted to be in a different room, I would take my Steam Deck and enjoy that. But with this device, for the first time, I can just put it on first, bring up my Steam catalog, and then pick and choose what game. And that can be a VR game or a non-VR game.
Yeah.
And that's sort of the focus of what we're doing. Like, it's cool that this supports some mixed reality stuff, but I wouldn't put that as one of the top tier points. I think it's really focused around the Steam catalog.
Joy, for tracking, you know, these controllers are tracked just like your Index controllers, but like obviously tracked in a different way with IR lights. But how do you guys think about input, and you know, what are the other input methods that you can get into Steam Frame beyond just your Steam Frame controllers?
Sure, because we support the entire Steam catalog, we need to support VR inputs, such as laser point and click, but we also need to support the gamepad. So for example, you have a D-pad on the left, and you have the ABXY on the right. We're using magnetic TMR thumbsticks, which are sort of next generation for reliability and low drift. And you also, of course, have capacitive sensing of the fingers for VR as well. So we have really the full range of inputs. So you don't have to think about, is this a VR title? Do I need to grab my VR controllers? Is this a non-VR title? Do I need to swap out to a different type of controller? You can just make that transition without having to even think about it. If you do want to use your Steam controller, you can actually use that with this headset as well. But this device, it works well without requiring you to make any decisions about what it is you want to do.
Is this the only track controller option, like that's tracked by, you know, in positional space?
So the Steam controller itself also has the LEDs in it.
Oh, it does. Okay.
So you can actually see the controller with this headset as well.
Oh, that's great. Yeah, I remember there was a whole generation of games, you know, like for PCVR, that you can see the representation of a controller, and actually is.
Yes, that was part of. I mean, that's part of the benefit of, like, we're all working on this together in the same building. We're all sitting next to each other.
Yeah.
So when folks working on the Steam controller project were thinking about the design and the features, the Steam Frame folks were also like, hey, you know, people are going to want to use that. It'd be great if that was also trackable when you're in VR. So we made sure to include that feature.
And in many cases, it's the same people. I know you you worked on all three products, I believe.
You just turn around, now I'm on the Frame team. Turn around, now I'm on the Machine team.
And this streams from Steam Machine as well.
Absolutely.
Yeah. So conceivably, you could be playing a non-VR game in a big virtual theater on the headset with a Steam controller, streaming from a Steam machine.
I know it sounds complicated, that there's so many sort of ways to mix and match, but our hope is that users won't even have to think about it. They'll just put on the headset and everything will just work.
How do you guys think about social experiences as, you know, people get these, and as Steamos is updated, and you know, that there's a shared language and platform? You know, are there dedicated social multiplayer ways to enjoy media together in headset?
That's a great question.
Yeah, it's something that we're really interested in. We don't really have anything to announce about that today, but we definitely have a lot of the features in here to support other people making those kinds of experiences, like the eye tracking and the hand tracking. I think that's about it.
Yeah, but like,
it's something you're continually thinking about.
Yeah. I mean, if you hark back to like when I was growing up, and you'd have LAN parties, and the ability to just sit and hang out with friends and share gaming experiences, that's something we all love, and that's a type of experience we're very much thinking about.
People do it on Steam all the time, right?
Absolutely.
Of course, you can communicate with the microphones and have a conversation.
And this is launching in the spring?
Early next year.
Early next
early
year.
2026.
Okay.
Yeah.
Yep.
What are the next hurdles to get this ready? I see packaging's already done.
Exactly.
Basically done.
The developer kit program is something we're introducing in mid-November, and so we're going to get them in the hands of a bunch of devs. Most software streaming we expect to just work, but there might be minor tuning, like for resolution or quality settings. The same way when we launched Steam Deck, partners made the types of tweaks like on Steam Deck, we'll run with the following settings because that looks perfect. We talked about the resolution and frame rate trade-off. Nailing those types of things is something we're excited to involve partners with.
Yeah, so the developer kit program is going to be crucial, and then kicking off the verified testing and growing that and learning more about what we need to change from a software perspective. That's kind of our next hurdles.
I guess my last question is, it's one SKU, right? One storage capacity.
Oh, actually, there's going to be two SKUs.
Okay.
Yeah, similar to Steam Machine, there was two SKUs. There's going to be a 256 gigabyte model.
Okay.
And a 1 terabyte model.
1 terabyte.
But everything else will be the same.
Yep, they'll all have 16 gigs of RAM, for example.
Got it. And accessories that you guys are now saying as a comfort.
Yep, the ergonomic kit, which includes the top strap for the headset, as well as the wrist straps, or not wrist straps, I'm sorry. The
hand straps.
Hand straps for the controllers, very much in the spirit of the Index.
And for the micro SD card, it's not just for SteamOS games, but any type of media content also works on that? Or you think of it works as extra storage?
Media content, it's certainly your computer, so you as a computer owner can do anything you want with that data storage. We tend to think about this as a gaming device first and foremost. So while we don't restrict or limit any media options, that is very much not our focus out of the gate. We'll see what people do with it.
Yeah, I mean, I would imagine that a micro SD card formatted for SteamOS to read it, if you go to desktop mode, you'd be able to open files in there and look at it from the file browser. So.
Yeah. Does a headset render in a standard, resolution, and is that configurable?
Well, the headset is locked to 2160 by 2160.
SteamOS, I guess. SteamVR.
Yeah, SteamVR and SteamOS, it's all dynamic.
All dynamic. Okay.
Yeah, so even when you launch desktop mode, it's less of a mode and more you hit a button and you have a desktop window, and it could be a big one or a smaller one.
Right. Okay. Well, I can't wait to go test it. Thank you so much for the time here.
Great, thank you.
Thank you.
So I have a little more opportunity to check about the display and optics of the Steam frame. So I have Josh and Jeremy again.
Yep.
Josh, you're the guy. You're the optics guy here. Tell me about these pancake lenses and how they're arranged here relative to the display that you chose.
Yeah, we're pretty excited about the design that we worked on here. First off, we're using the pancake optics. These are cat-a-day optic systems. The nice thing about a cat-a-day optic system is it lets you use a refractive element and a reflective element. And those two parts of an optical system, they kind of complement each other to allow you to correct certain aberrations. So the pancake optic in general is just a really good fit for VR, we think. Specifically, we've worked hard to make the quality of the surface really good, because that kind of drives the sharpness and the image resolution that you'll see. So we put a bunch of work into making sure that what we call surface figure, or the correctness of the lens, is as good as we can mold. And then we've done some stuff with, we also have a glass element in there that we use to make the surface extremely flat. But we made that glass element as thin and as small as possible, so the weight isn't. You're not feeling a lot of weight from the glass element.
Yeah.
But all of those together allowed us to really just try to control the image quality and get the sharpness. We did a lot with balancing the FOV and the angular resolution across the display, so that when you're looking at things like 2D content or menus, it's still a readable experience.
I'm always curious about these trade-offs, because it sounds like even when you're looking at the category of pancake optics, it already sounds like you have a whole buffet of options of materials and thicknesses and coatings and sizing, and you just listed out some of those priorities. Give me a little more insight about how tough it is to make a pancake optic that works this well or to your specifications.
Yeah, I think what's unique about what we've done, which being at other places, I haven't had the opportunity to do this as much, but we bounce all of these ideas off of each other and engineers working on this. So, I'll work on a design that I'm really excited about and think it does the thing that I want it to do, but really it comes down to the experience. And so if I hand this to somebody like Jeremy or anyone else on the team, and they're like, oh, that was cool, the thing that you worked on, but I care about this other, I care about sharpness, or I see a little flare somewhere that I don't want to see. And that gets incorporated in the design really early, because we're so we're so quick to show it around, and that design has caused us to do so many variations. I mean, we went through the whole alphabet of like design A, design B. It's just like just a ton of designs, and we quickly, by kind of iterating quickly and learning, we kind of really focus on the experience, and that has really changed the way you do a design. Because a lot of times in optical design and camera design, it's a really known thing. You go after MTF sharpness. You go after certain qualities, and it's a thing on a piece of paper. But this is interfacing with human eyes and a human experience, and that has really been the driving performance metric for these optics.
I remember early on in our prototyping for what would become the Steam frame, Josh showed us a headset where we knew we wanted to attack non-VR content pretty early. So you showed us a headset that had greatly increased pixel density at the cost of FOV. And we were thinking, you know what, we know we want to also function as VR, but let's put VR aside where we know the FOV is amazing. And let's just really increase the pixel density by having a smaller FOV. And we put that on, and we play tested it amongst a bunch of people in the building and on our old team. And what was amazing is we started hearing words like, I feel claustrophobic. And even though the rectangle of this huge theater was fully enclosed within the VR, within the field of view, like it wasn't that the picture was going beyond the field of view, but just not having stuff at the periphery just gave you this claustrophobic feel. And so I remember we went back to you and we said, well, it turns out that FOV is really important, even in non-VR gaming, which was like a great surprise to us. And it's not something you can just learn on a piece of paper. Like we had to build it, we had to try it. And that's where we landed at this FOV, for example.
And even something like having light leak, having just a little bit of light coming in or air coming in, right? Feel less claustrophobic. It all goes into the type of experiences. I remember when I was first here for the index reveal, and one of the novel things that you guys did was cant the displays. Jeremy, can you talk about how the displays are aligned here to your face and to the optics and what you're doing to...
So I guess to start with, I would say these are 1-to-1 aspect ratio panels. We mentioned that they're 2160 by 2160 per eye, but the picture area, the active area that actually emits light, is not a perfect square. So if you notice on the bottom, this is where the panel would be. It's actually truncated, it's cut off. And so even starting with the shape of the panel, that bottom, sort of the edges being cut off, and I could get you a better graphic, allows your nose to fit in there comfortably. So it's a very custom panel shape that allows your nose to fit in there. And then as far as canting refers to this angle, right? To allow you to perhaps have additional field of view in the horizontal direction because you don't need 100% binocular overlap. And you can go too far on that, right? Like for example, you could have one eye pointing this way, one eye that way, and then you sort of see across your nose and it feels really weird. So there is canting on this, very similar to index, but it's a very modest amount. So if people do any of those applications that allow you to measure FOV, you'll see that we have nearly full binocular overlap. But just that little bit extra allows you to get a better sense on the periphery.
There's a couple elements to that. Is when we do the canting, a lot of what drives that, and we did some user testing with this, is your face isn't perfectly flat either. And so by putting just a little bit, we're finding for a lot of cases, we weren't actually trading off field of view by doing that. We were actually allowing the lenses to get closer to your eyes, and that allowed us to actually get some of the field of view that people who might struggle with binocular overlap were able to get a little bit back. But again, it really comes down to the facial shape and how this is adapting to your eye. That field of view number and the canting, we kind of target the average and kind of as big of a majority of people we can cover, but it does vary.
You say about 110 degree average field of view, again, depending on the eye relief and how close to your face and your face shape.
Closer is better.
Yes, of course. Yeah, some people love eyelashes touching the lenses. What about binocular overlap? How much overlap are you targeting on average?
So that number is really hard for us to report out, and it's because of the fact that we have this, it's not a circular aperture. And so when we want to talk about what's the horizontal field of view, for example, it's really easy because we can take the max number here and the max number here, and it's circular. So there are places where there's, like Jeremy's saying, where there's like 100%, depending on what your IPD is and where you fit. And then there's places where with the decut, like even for a lot of people, they don't have 100% binocular overlap because their nose gets in the way, and so we have to account for that. So it's a hard thing to answer. There are some people also with glasses that obstruct the binocular overlap. You can have cases where you don't have a lot of binocular overlap, or not as much as we would like. It's a function of how it fits on your face. And then there's some people who get great. I mean, for me, I think I'm getting something like 90% binocular overlap for when I wear it, and it feels great. I can see the whole screen.
Yeah.
I will say that we really love to be quantitative as much as possible. Like, I would much rather say this back, like, it's exactly this angle and exactly that. It's just that FOV is one of the hardest areas to accurately measure in a way that is predictive to someone's personal experience.
Yeah.
Like, we go to enormous efforts to calibrate these lenses, right? Like, we put cameras very close. We know per pixel the exact location as a function of angle that a human would see under ideal conditions. But it's very hard to translate those numbers into the experience someone has had, because they might think they're seeing 110 degrees or 120 degrees FOV, but they might actually be getting 90 something. And that's where some of those applications that let you actually look around, those are sort of the best way to actually test it, to know what you're getting. There's even, we don't have to go that deep, but like the FOV you get looking on center is different from the FOV when you look over.
Right.
Like, it's very common for you to like look
That's why your
forward.
tests, you look forward and then you kind of wait for
you can look forward, but attend in your brain to things off in the periphery, which is a different number than if you look over.
And
So
we
it's-
report all those things, and when we do this design and when we do measurements across different faces and stuff, those are numbers we collect, and they are incorporated in the design. It's just it's so many numbers that it's really hard to just say a number.
Also, for people who wear corrective lensing, what are the thoughts, and how is potentially going to support corrective lensing?
Well, we did a bunch of work on Index. We had a bunch of corrective lenses that just weren't dialed into the quality that we wanted. So people would not put them in right or whatever, and then that experience just wasn't great for them. So we've been working on corrective inserts for Steam Frame, because we want people to be able to put in inserts and still have a good experience. And we found that it just turns out we can encourage, or we can create an experience that's more dialed in for people if we work on that with folks. So we've done a bunch of work to dial that in and make that as rich of an experience as we can, and we're just in the process of trying to make it available for people.
Do you have thoughts on variable diopters and the pros and cons of adjustable diopter in lens?
Yeah, we looked at that. There's a lot of trade-offs in the mechanical design and the optical design, and it complicated the system to a degree that we just felt like we couldn't we couldn't make a good experience for everybody, because even if you do have corrective diopter adjust, you still have people with astigmatism, and so it just doesn't solve everything. So we kind of feel like we've been able to create inserts that work well for people, and we're kind of leaning into that right now.
Awesome. Thank you both so much for your time.
Yeah.
Thank you.
Thanks.
Okay, so there's so much to process and digest about this news, about the Steam Frame. It's been about 2 weeks since we were up there to learn about it, and I was able to try it, but I've had some time to think about it, because it's given me a lot to think about. And to be clear, I spent about 20 minutes or so total in the headset trying a variety of different experiences, but mostly the three that we talked about in the interview: flat screen, local gaming, local VR play, and also streaming VR from a desktop in playing Half-Life Alyx. And my initial impressions is that, one, this is a really light headset. If they were going for comfort, I mean, this is way lighter than any even standalone headset I've tried so far. I mean, the idea of minimizing the weight of that compute module, and they use the words "every gram counts," sounds familiar, right? Really felt like it mattered here. 180 to 190 grams for that front compute module. The battery in the back, I was skeptical that because it's using soft straps, that would actually help and assist as a counterbalance, but maybe because of how the headset was not sticking out from my head and how it wrapped around my face, it actually worked out ergonomically. Just it didn't feel very heavy, the whole thing. It is soft straps. I mean, it kind of is like this idealized version of what we thought VR headsets would be like. Like, if you've seen Ready Player One, we saw like this, the VR goggles look like ski goggles, and these kind of remind me of ski goggles. But in using it, the optics and the displays reminded me a lot of the Quest 3 and the Quest Pro. The pancake optics here have a really generous sweet spot. The eye box is really nice. I mean, even though the headset's pretty tight to my face, did try moving it around, and the clarity was really edge to edge. The wider field of view than I would normally expect from something like the Quest 3 was noticeable as well. Although so much of this headset reminded me, image quality wise, of the Quest 3, from the pancake optics, from the use of high resolution, LCD panels. And let's talk about the use of LCD panels here, because the biggest surprise going into this, and with all my hopes and the rumors and suspicions, was that they're choosing LCD panels over going with a high resolution micro OLED. And I've been racking my brains over the past 2 weeks thinking about what about this makes sense, as what they're calling a premium standalone VR headset. The resolution of these panels are the same resolution as we saw in the HP Reverb, although that one had a much lower field of view. So 2160 by 2160 per eye, cropped a little bit on the corners here. If you do the math on the number of pixels that's being pushed, it's actually really comparable to what the Quest 3 panels are. Those are a little off, like 2000 by 2200 or so, but they're very similar in that they're also LCD panels that are angled inward. And so a lot of the characteristics of those pixels not being like square pixels, more like diamond shaped pixels, at least to the horizontal plane of your eye, I felt like that was here too. Of course, Quest 3 is running a much weaker processor, and by default, the Quest 3's rendering resolution is much lower than the native resolution of the panels. And here, the assumption was that what they were showing me with the Steam VR interface and what they were streaming at was at least hitting the native resolution, if not higher than. Actually, I know for higher than because I was able to go into Steam VR settings. It was like at least 3,000 pixels wide, doing a little bit of super sampling than the native resolution of the LCD panels here. But it reminded me a lot of that Quest 3 experience, the clarity of the edge clarity of those pancake lenses. And in thinking about why choose LCD with these pancake lenses versus a micro OLED approach like we saw in Apple Vision Pro, the Play for Dreams MR, and Galaxy XR, I think it boils down to a couple reasons. One, probably cost. So there's no price announced for the Steam Frame. The words that they told me was that they are seeing this as a premium standalone VR headset with a targeted price of under what the Valve Index costs, and Valve Index is $1,000. It's not a promise that it's going to be under $1,000, but that's their hope, and that's actually, I think, pretty. If it's $999, I think that's a pretty good price for the technology and what they're putting in this headset. It's not $1,200 as some of the rumors indicated. But with that price tag, with that bill of materials, they have to pay for optics, manufacturing, panels, as well as the processor. And so choosing all of these things, plus all of the extra audio hardware and the battery and all that stuff and the controllers and the router stick, all of those have to fit under. So getting a bill of materials, getting a reasonable price, mass market price, as like the Steam Deck has become, like that was probably a big goal of theirs. Two, field of view. You heard them allude to this in my conversation with Jeremy and Josh about how they chose the optics and the panel for this. And they specifically talked about having prototypes where they would have a higher angular resolution, so higher pixels per degree. Not sure if that was with LCD or OLED, but at the expense of field of view. And they said their testers felt that was too claustrophobic. And especially for a device where one of the main use cases isn't just for VR games, but for flat screen games, I think they prioritize field of view. And I agree with them. Field of view is one of those underappreciated attributes of VR headsets today. And with micro OLED panels, with pancake lenses, it's hard to get a really wide field of view. I don't see it in the Vision Pro, for example, today. I want more field of view from that. And then finally, there's that balance between display optics, of course, and also the processor and what chip they've chosen and for what purpose they've chosen to use for that chip. And a surprise here was that they're not going with Qualcomm's XR2 Plus Gen 2. I know, very confusing. That's their Snapdragon XR chip variant that's in the Galaxy XR. It's a generation, it's an overclock version of what you'd find in the Quest 3 and the Quest 3S. But that chip, that XR chip, was specifically designed for mixed reality. So a lot of digital signal processing for camera input. And Valve has told me mixed reality not a big priority. They're monochrome cameras that they've used for their inside-out world tracking. And the Qualcomm XR2 Plus Gen 2 can have display throughput of up to 4,000 by 4,000 pixels per eye, up to 90 hertz. So something like the Galaxy XR, I think that's like 29 million pixels, and that goes up to 90 hertz. The Steam Frame, with its 2160 by 2160 panels at up to 144 hertz, even at the max spec, you're only pushing half the number of actual pixels per second, even at 144 times. That's the difference you get from going from 2.1K per eye to 4K per 4.3 or 4K per eye. And that means that without the need to use that XR chip, they're actually choosing Qualcomm's high-end smartphone chip, the Snapdragon 8 Gen 3. The names are terrible. Let's just all agree on that. Snapdragon 8 Gen 3, which is in like, I think the Galaxy S24 or something, that actually uses a higher clock CPU and GPU than the XR chips. You're talking about a max CPU frequency of 3.3 gigahertz versus 2.4 gigahertz, and that's on performance cores. And on the GPU side, the Adreno 750, it tops out at 900 megahertz versus the overclock 680, like 700, high 700 megahertz of the XR2 Plus Gen 2. Still got it right. And that makes sense. So by choosing lower resolution panels, they can get 144 hertz. They can get higher processing compute and graphics compute so that they can play some of these flat screen games natively at an internal virtual resolution, as I saw in Hades 2, of 2560 by 1440. So clearly a priority for them to have games at least run competently on headset, VR games included, adapted via VEX and also Proton. But as I asked the team there, and they told me it's still not as powerful as the Steam Deck, because this is using an AMD APU, essentially a laptop graphics processor, and the Steam Frame is using a high-end cell phone, high-end smartphone processor. There's sheer fundamental different types of architectures and thermals that they've been designed for. The Steam Frame didn't get hot as I was using it. I definitely felt the vent though, the exhaust of that. And like I said, I only was able to spend a couple minutes in each of the different types of experiences. I will say that as someone who's very familiar with testing VR headsets and scrutinizing the details, using the Wi-Fi router stick to stream Half-Life Alyx to the Steam Frame, I didn't notice in my time with it any compression artifacts or any banding. Now it's an LCD, so the black levels weren't as black as an OLED panel, and the brightness was something that I felt like could have been improved, but it looked really crisp. Like if someone told me that was a tethered connection in the little time I had, I would have believed them. But at the same time, it didn't look as sharp or as high resolution as a Big Screen Beyond or the Somnium VR1 or another, a micro OLED or high resolution desktop VR headset that I've been using. And just putting the Russell gloves and Alyx up to my face and holding the other objects, like there were details there that I could not see in the Steam Frame that I know in the past I was able to see in those in the other high-end VR headsets. So it really feels like they've designed the Steam Deck of VR headsets, something that they hope and they say can run games competently locally, but also works really great streaming. And streaming here, I think, is the big surprise, that dedicated Wi-Fi 6E USB router that has that strong connection with their foveated encoding, the foveated streaming. Remember, this is the PC side running the games at full blast, full resolution, with super sampling, whatever you want, whatever your graphics card can handle, and then Steam Link, Steam VR, doing the sampling of your eye tracking and then only sending and concentration of those pixels to where you're looking. And it's not something that I can show you. I wasn't able to see or give you that visualization and get that captured, but I was able to toggle that when I was there, and they were able to show me this grayscale eye tracking box with a gradient that fell off from the square from where I was looking at, and the eye tracking looked responsive, and I could definitely tell that there's a lot more detail in the center, even though once I toggled the full graphics on, I couldn't tell the difference between, I couldn't actually notice the effects of foveated streaming. The Wi-Fi stick will only work with the Steam frame, so I'm a little disappointed that's not a product that they're just making and certifying for other VR headsets or VR devices. That would be really neat to have. But one great thing to note is that Steam Link 2.0 beta that's currently out now works with devices that have eye tracking. So the Quest Pro, the Play for Dreams MR, which have eye tracking, can actually take advantage of foveated encoding. It's not going to be a feature locked to the Steam frame. There's gonna be so much more to test. We're so curious about battery life, about performance for these games locally, about games that potentially could be sideloaded, because it's a PC, right? Like I said, this is shipping in spring 2026. We don't have a price, we don't have pre-order plans, but this will be launching in the same time frame as both the Steam Machine and also the new Steam Controller 2. And I'll have a separate video with my thoughts and conversation with Valve about those devices coming out later this week. But I'd love to hear from you out there, especially of those of you who are still active in the PCVR space. Like, how do you see, what do you think now that all the information is out there? Is this the headset you're hoping for? What were the surprises to you? Let's continue the conversation in the comment section below. But thanks so much for following along and watching. And thanks to Valve for having us up there to check this out. I'm Norm from Tested, and that was our first look at the Steam frame.